All right, so make sure as you get started, you have the notes either from Friday or from on the table. If you haven't picked them up yet, we're going to go ahead and do notes like this. Now, if we ever get shut down, this is how we're going to do notes as well. You can't skip forward. You have to watch this video through Edpuzzle to be able to get credit for this. Make sure that you're paying attention and copying notes as we go because this is your lesson for today. So the first thing we're going to look at is functions. So our function is a relation where every x has only one y value. Okay, only one y values. A relation is just a set of data. In our case, we're normally talking about ordered pairs, x comma y, set of ordered pairs together. Now, what makes a relation a function is when every x value only has one y value, and it's a distinct y value. So let's look at each example here. This is determine whether each of the following correspondences is a function. So this correspondence, each x value, here's an x value, here's your y values. Each x has only one y value. What would make this is a relation because it's a set of data. What makes it a function is that every x only has one y. For example, if this 0 also had an arrow to the 9 here, this would make it not a function because this x value is two different y values. It's okay for the y values to be repeated. Okay, for the y values to be repeated. So let's look at this. Sometimes their set of data is real life data, and sometimes it's just ordered pairs. So here our x values are appointing presidents, and our y values are the Supreme Court justices. So in this case, we have a relation. So both of these here are relations because they're just both sets of data. But let's see if this is a function. So for it to be a function, every x value has only one y value. Your x cannot have more than one y. So here, in this case, George W. Bush does have only one y value. However, the rest of these have two different y values. This says that it's not a function. Oh, and we said that this first one was a function because each x has only one y value. All right, let's look at these examples. A, B, C, D, E. It asks whether this is a function or not. So this is a yes, a function, no, and not a function. All of these are relations because they're all sets of data. The first domain is years in which a presidential election occurs. The correspondence is the person elected, and the range is the set of presidents. So our example here is like we have 2020 is a presidential election year. We had 2016, 2012, 2008. These were all presidential years. The y values are a set of presidents. So we have Trump, Obama, Bush. Okay, so is each of these x values here going to have only one y value? Well, in 2016, we elected one president. In 2012, we elected one president. In 2008, we elected one president. There is no way that you can elect more than one president at a time. So this tells me this is a function. So the next one is all automobiles produced in 2016. Each automobile's VIN number is in a set of VIN number. Now, if you don't know what a VIN number is, a VIN number is called a vehicle identification number, and each vehicle has a distinct VIN number. So since every automobile has a different VIN number, there's no way one automobile can have two different VIN numbers. So this tells me this is a function, right? So if one of these can have two of these, that means it's not a function. If one of these can only have one of these, function. So let's look at the last two are inverses of each other. Remember, inverses are when you switch your X's and Y's. So if we look at this one, the set of all professional golfers who won a PGA golf tournament in 2014, that's our X's. And then our Y's is the set of all PGA golf tournaments. So here we have golfers. So we have Sam, Bob, and Tiger Woods, because he's the only golfer I know. So the set of all PGA golf tournaments. So we have tournament 1, 2, and 3. And then, of course, they do keep going. We have more than just 3 tournaments and more than just 3 golfers. But is each golfer only going to win one tournament? So Sam would win one tournament, Bob would win one tournament, and Tiger Woods would win one tournament. That's not necessarily true, right? Tiger Woods can win 2 tournaments, or Bob could win all 3 tournaments. So since each X value could have more than one Y, this is not a function. So let's flip them. If we flip them and say, all right, we want to look at the tournaments as our X value and the people as our Y value, does each tournament only have one winner, or can it have 2 winners? It can't have 2 winners, right? Tournaments can't have 2 winners. We're not going to talk about ties. You can't have 2 winners for one tournament, right? So since this is never going to happen, you can have something like this. This is going to be a function because each X can only have one Y value. It's not possible for it to have 2 Y values. All right, moving on from functions. We have function notation, f of x. Remember, f of x is another way to write y equals. So find each of the following. Remember that when you say f of 0, this is just like when we say f of x. This is not f times x. If you multiply by x, it is going to be incorrect. If you multiply by 0, that's going to be incorrect here. This says that x equals 0. That's what this one says. X equals 0. So if you plug in 0 anywhere you put an x and reduce it. So that's what we're going to do. Go ahead and plug in 0. So I'm going to start with this function right here. Starting with this function. Plugging in 0 anywhere I see an x. I'm going to start writing it down. 2 times. Oh, there's an x. I'm going to put 0. Always plug it in parentheses. Quantity squared. Minus 0 plus 3. Well, order of operations tells me to do exponents first. 0 squared is 0. 2 times 0 is still 0. Minus 0 goes away. This equals 3. There's your answer. So if we do negative 7, I'll start this one. I want you to finish it. 2 times, instead of x, we're going to put a negative 7. This tells me that x equals negative 7, and we're going to substitute it in right here. So 2 times negative 7 squared minus a negative 7. Now notice that I put a minus a negative because this is the minus from the equation, and this is the negative 7 from the f of negative 7 here, right? Then you have your plus 3 at the end. Again, I'm getting these numbers from up here. Okay, go ahead and try this one on your own. All right, you should have gotten 108, and if you didn't, then you need to go back and look at my work up here and ask me questions later if you need to. So now these last two are just a little bit harder. Instead of putting in a number and getting a number out, you're going to put in an expression and then you're going to reduce it. So again, this says right here, wherever you see an x, you're going to replace it with 5a in parentheses. So this equals 2 times 5a quantity squared minus, in parentheses, 5a plus 3. So start with order of operations. Exponents first. 5a quantity squared is 5a times 5a. So this gives me 25a squared minus 5a plus 3. We can just drop the parentheses there. There's nothing to do. Then 2 times 25a squared is 50a squared minus 5a plus 3. And in this case, this is our final expression. That's the answer here because you can't get a number, can't combine a squared and a together. That's your answer. All right, here we go. Last one is the hardest. This equals 2 times, instead of x, right? This is what we're going to put anywhere we see an x, a minus 4. So we have 2 times a minus 4 in parentheses squared minus, in parentheses, a minus 4 plus 3. All right, first thing got to do is exponents. This a minus 4 quantity squared, that is not a squared plus or minus 16 either way. It's not that. You have to come off to the side here, and squaring something means multiplying it by itself. So you have to go a minus 4 times a minus 4. This gives me, we have to FOIL. Remember, that tells you first, outer, inner, last. We're going to multiply. A times a gives me a squared. A times negative 4 gives me negative 4a. Negative 4 times a gives me negative 4a. Negative 4 times negative 4 is plus 16. Combine like terms, which is these middle ones. A squared minus 8a plus 16. So I'm just going to plug that back in over here. For the highlighted thing, 2 times a squared minus 8a plus 16. Then minus a minus 4 plus 3. All right, next thing we're going to do is distribute. We're going to distribute this 2 to everything inside this parentheses. And this minus is really a negative 1. We're going to distribute to everything inside that parentheses. So this gives me 2a squared minus 2 times negative 8a is negative 16a. 2 times 16 is plus 32. Distribute. Negative 1 times a is negative a. Negative 1 times negative 4 plus 4 plus 3. All right, combine like terms. A squared is the only one. 2a squared. Then we have a negative 16a and a negative a. So that's negative 17a. Then we have 32 plus 4 plus 3. So 32 plus 4 is 36. Plus 3 is 39. And that is your final answer. That's what we would put into MyMathLab. All right, moving on down. So now we're going to use a graph to find the same thing. Honestly, I think using the graph is a little bit simpler than having to plug it into an equation. So please, please, please don't make this hard. So the first thing that you're going to do is f of negative 3. Well, what does that mean? It wants the y value when x equals negative 3. That's what we're looking for. Y value when x equals negative 3. So here, if we find x equals negative 3, well, this is right here on my graph. X equals negative 3. All I have to do is find the y value. Well, this is where it intersects with the graph. The y value of this ordered pair right here is positive 3. So your answer here is just positive 3. Same thing for f of 1. Here's my x value 1. It intersects the graph down here. What is the y value when x is 1? Well, the y value is negative 5. All right, your turn. Go ahead and try f of 0 on your own. F of 0. So this means when X is 0, find the y value. All right, your answer should be -6, and it's from this point down here. For 0, that's where the graph is 0 at x, and the y value there is -6. Okay, the vertical line test. I know you've seen this before. Vertical line test tells you whether the graph is a function. Tells whether a graph is a function. So the vertical line test is basically if you draw a vertical line anywhere on the graph, if it intersects the graph more than once, it's not a function. If it only intersects the graph one time at every single vertical line, that means it is a function. So let's look at some examples. On A, if I draw a vertical line anywhere on this graph, it will only intersect the function one time. This tells me, or it only intersect the graph one time, which tells me it is a function. If we look at letter B, if we draw a vertical line right here, it does intersect the graph only one time, which is good. However, if we draw a vertical line right here, it intersects the graph 1, 2, 3 times. So since there is a vertical line, it doesn't matter that there's some on either end that do only intersect one time. It's if one of them fails, the entire thing fails. So here, this is not a function, since all three intersected that vertical line, right? It intersects the graph more than one time. So let's look at letter C. Here at this point, there's my vertical line. It intersects the graph more than once. That tells me it's not a function. Go ahead and do D and E on your own. All right, you should have gotten not a function for D because a vertical line will intersect the graph more than once. And you should have gotten function for E because anywhere you draw a vertical line, the vertical line will only intersect the graph one time. So let's talk about F. I want you to make a prediction about F really quickly. Go ahead and try and decide whether you think it's a function or not a function. All right, well, here, if we draw a line in all these vertical lines, it does only affect the graph one time. However, this is my problem right here. This one little x value at -1. That would be my problem vertical line. Well, if you remember that a filled dot means it's included, this is part of the graph. This is part of the graph right here. But this empty dot means it's not included in the graph. So even though there's a dot there and it seems like that vertical line would cross the graph twice, it doesn't because it's an empty dot, okay? So this one is a function.